Getting the slideshow up and running. So yeah, as I said, my name's Christine. I'm one of the project consultants here at head office in Markham in the Hawke's Bay. I've been working for Markham now for about 3 years. And so yeah, happy to be here presenting about durability and waterproofing and how that links. And I'm joined today by Henry as well. Henry, do you want to introduce yourself?
Yeah, thanks, Christine. Yeah, hello and welcome to everybody that's online today. Thank you very much for joining. Yeah, as Christine said, I've been with Markham for about, time flies, I think it's about 9 years now, specialising. I did some time in the Aussie team over there, and now head up the New Zealand construction project side of things. So yeah, thanks for that intro.
Perfect. Yeah, we're going to keep this reasonably short and sweet today, but hopefully it'll be punchy enough for you to actually grasp the concept. You can ask questions at any stage. Like if something occurs to you that you'd like to know more about, there is the little Q&A tool down the bottom. And so if you're typing those in at any stage, we'll get to those at the end of the presentation. But first of all, we're just going to kick off with a welcome poll so that we can understand a bit more what your motivations are, and we'll see if we can tailor the presentation as far as that goes. So yeah, if you just want to select who you are and what your motivations are, and then we'll get started. So we'll leave that up for a few more seconds.
Answers should be coming through any second now.
We'll share those with you. A couple more seconds. Yep. Oh, we've got almost an even split today. And so we've got structural engineers and architects and people interested in new technologies. So that's helpful. We're going to cover those, and all of the information should be perfect for structural engineers and architects. So yeah, perfect. We'll crack on with that. So essentially, as mentioned, today we're going to be talking about the link between waterproofing concrete and protecting the internal steel. So to start off with, why does steel corrode inside concrete? Concrete can be thought of as quite an impermeable product, but it contains tiny capillaries, which are highways for moisture, and traveling on the back of that moisture is contaminants, chlorides, etc. That's able to get to the internal steel and start breaking that down. So Henry, do you want to talk a bit more about what's happening in terms of that steel breakdown?
Yeah, no, thanks for that, Christine. Interesting topic this. We all think concrete is impermeable, but it's actually just a big sponge. Even 40 or 50 MPa concrete, we still know that moisture finds its way through the weakest link, I guess, in the concrete. There's also some other drivers. So what drives most concrete internal reaction? There's a few different things here you guys probably know a little bit about. You might not, but we've got the standard ones here. You got ASR, you got carbonation, DEF, and just to unpack them a little bit more. So your ASR is obviously your alkaline silica reactivity. You got sand or certain reactives in the aggregate that when moisture hits it, it obviously swells and you get breakouts in your concrete. It doesn't always happen in every part of the world. There are some, even here in New Zealand, there's only certain parts of the country that it happens in, but it is quite common. You got carbonation, so as long as CO2 can get into concrete, you always have problems. DEF, so that's basically where there's unreacted cement, or if you like, the curing process has been done too fast and the cement particles don't react like they should, and therefore cause problems down the track. So I guess that's a few of the issues, and that's round about our why with Markham, why we waterproof structures. Our mission's adding life to concrete by providing sustainable solutions. Our vision is to save the world by one concrete structure at a time. And so it's when we these problems do occur, they occur closely to occurring close to home than we sometimes like, and there are some sensitive projects. Some of you will know what's going on the other side of the world now, and caused by certain types of concrete cancer, if you like. So we're all about educating people on these issues, and following on, it's all, as Christine said earlier, moisture. Really, all these contaminants relate to moisture in concrete in some way. Contaminants jumping on the back of moisture and getting in and out of concretes in wet and dry tidal zones, marine area environments, moisture getting in and reacting and causing the likes of ASR, moisture getting in and reacting unreactive cement and DEF, that sort of thing. So the moisture migration is the transport system. And what we like to talk about is waterproofing the concrete, whether it's existing structure or a new design. But if we can stop moisture migration in and out of concrete, we can stop a lot of problems in concrete. And that's the start of where we like to go. And that's essence of adding durability concrete is really a simple solution, is by waterproofing it with the hydrogel treatments. And you guys out there might have heard of some other treatments out there, internal pore blocking treatments, that sort of thing. The hydrogel form is formed inside the pores and the porosities of the concrete. So you can see our untreated example on the left there. You got your wet and drying and your water coming in and out. So a concrete porosity is about 50 nanometers. A human hair is about 100,000. So you can see how fine the particle is. The hydrogel particle gets down to about 10 nanometers. So even when we spray apply this to the surface of the concrete with existing concrete, we can get deep penetration into concrete up to 150 mils. It reacts with that moisture in the concrete. It forms the hydrogel in the concrete. It's in there for the lifetime of the concrete, and therefore stopping that moisture coming in and out of concrete, even under hydrostatic pressure. So that's the kind of example we like to talk about. Have you got anything to add to that, Christine?
No, I think you've covered it off. I mean, we've got a few ways of achieving this. Henry touched on both admixtures and spray applied, where we can transform that internal moisture into a hydrogel. I think next, have we got some case studies?
Yeah, we have. Yeah, I'll chop across there. Yeah, take us away.
Yeah, cool. So in terms of that, we've got the Blewett Wharf as one of our prime examples. Anyone who's been in Auckland or who was watching the America's Cup would have seen this in the background. That wharf was actually destined to be demolished way back when. So in 1999, we were brought in to spray apply the top deck of that. We waterproofed the top. We also sprayed underneath there. And at that stage, the deterioration was quite severe. And so when this was a remedial project, so obviously not getting in at the front end, but with our hydrogels, we were able to halt the corrosion. So it doesn't reverse it, but we were able to hold it in place. And then 10 years later, when the checks were done, an independent engineer went and checked that, and areas that had significant deterioration, showing where they'd ringed it in paint and going back to check, those were completely benign at that stage. Interesting
fact around that, Christine. The wharf used to be used as some type of, they used to cut some type of chemical, and there was a lot of splash over, and it basically it formed a lacquering effect on the underside of the wharf. So the chlorides were coming up and splashing onto the top of the wharf from the sea and the waves and that, but it was actually, they didn't have anywhere to go in the concrete, so it actually trapped them in there, and they were just going around and making more of a problem. And so that was a really an issue there. And it's like in the old ways of doing it, is putting a membrane or some form of bandage on. There's just a bandage over a broken bone. It's not really fixing the problem. It's the problem's still there. So the hydrogel halts the corrosion process by really attracting those chlorides and not letting them move around the concrete because you haven't got that wet and dry cycle.
Yeah, absolutely. And so on the back of that success there, just the neighbouring Ports of Auckland car park elected to use our full waterproofing system on the new one at Ports of Auckland. So that is taking care of business in terms of stopping chlorides coming in and out from day one. So admixtures and then spray applied, getting a really good quality cure as well. I mean, in terms of that, there's lots of options, especially for marine environments, to protect them, but often they are a surface coating which needs reapplying. The great benefit of going with this hydrogel solution is that it's permanent. It doesn't need to be reapplied. That's not going to be able to be abraded off because it becomes part of the concrete matrix and the concrete structure itself.
Yeah, interesting that you say. Also, there has been research done, but any structure within, I think they said, I read some research within 20 k's of the coast is still susceptible to chlorides, airborne chlorides. So any exposed concrete is at risk, really. And yeah, we just want to make sure we don't start that corrosion process and that whole concrete cancer thing come along, do we?
Yeah, absolutely.
So sealed from day one protection. Another project a wee bit further from home, the Blewett Wharf in WA. So this wharf was treated to the top and the bottom, and the requirements around that from the consulting engineers was they wanted a minimum of a 50% reduction in permeability on that structure. Obviously, we did some on-site testing there as well, some independent on-site testing before we completed the whole wharf, and there's pretty awesome results there coming in. We got about a 75% reduction in permeability. That was carried out with the GWT testing, pressure testing on site. So really, really cool results there, and obviously adding life to their structure for years moving forward. Once it's in the concrete, the hydrogel is reacting in the concrete. You can't wear or braid it off. It's in there for the lifetime of the concrete, so we can therefore add the life, halt any corrosion process from there on out. And saying that, if there was a wharf that was starting to spoil and starting to break down and exposing Rio, obviously we'd have to work in conjunction with some repair mechanisms there. But if we can get to it early enough where your structure's still got its intact and that sort of thing, we can obviously save your clients a lot of time and money.
Yeah, perfect. And pretty close to head office, this beautiful picture of a human waste digester tank. So our admixture products were utilised to waterproof this structure, but obviously in an environment like a sewage digester tank, you've got really serious risk of chemical attack to the concrete. What can happen in these sorts of scenarios is that the waste creates a reaction with the concrete itself. And so our admixture was utilised to both waterproof and protect the structure itself from attack. Concrete is used often in these sorts of scenarios, and it can be difficult to protect it. And so our admixtures were utilised in those panels and our gasket in between, and they are still looking great and working well.
I guess the point there is also, Christine, is that we're not saying this is the be-all and end-all of systems. We do work in conjunction with a lot of other systems as well. In very high corrosive areas, obviously we can't say we're going to totally halt the corrosion process, because obviously if we're inside the concrete, your surface in these harsh environments will get abraded away. But what we can say is by waterproofing the concrete, we can give it a lot more durability and give that surface a lot more durability, so we just extend that period out more in these circumstances. But there are some pretty cool results. We can send some through of testing we've done and projects we've done around acid smelters and things like that, where the concrete takes a really hiding. But so that is just about a wrap up. We'd like to open the floor for some questions now. I'll just close this off, stop the share. So if anybody's got any questions, we would be open to answering them, or if they would like to see any testing or any reports as such, we're more than welcome to send that sort of thing through. So we're a very project-focused business, and we work from design through to installation. We don't just sell products. All these systems are installed by our approved applicators that work in-house for us. That way we can QA and give the likes of a warranty, 25, 30, 40, 50 years performance warranty to your project. So, yeah, I'm opening up the floor for questions.
Yeah. Anything at all pertaining to concrete and waterproofing.
What are some of the challenges you guys have had out there before in the past, and anything come to mind, challenges that you've had, and we might better add or give you a quick summary or a solution?
Okay, failing with that. Do you want to talk a little bit more about our warranty side of things, Henry?
Yeah, no problem. So, as I said, we give an insurance-backed performance warranty. This is QA'd and checked from our head office here in Napier. We've got our office in Sydney that will obviously run through Aussie projects, but we're not just selling a pail, we're actually there for the lifetime. We've been doing this 25 years now, flying about 150,000 squares per month across ANZ, New Zealand and Australia. So we've got a lot of track record there, but we have got another question.
Yeah, about durability and whether we can issue a 100-year durability certificate.
Yeah, definitely. So great question there. Yes, we have actually recently done a project in Auckland with a 100-year waterproofing durability warranty. That was a conjunction of a whole project that we worked from design through. So yeah, we're very project specific. We're more than happy to weigh up the risk and look at a project from the start and come back to you with a solution. So yeah, fire us an email and we're happy to chat.
And
that's a great question. How do you convince asset owners the initial cost of admixtures are worth the upfront expense?
Yeah.
Brilliant. Because we're dealing with so many asset owners on repairing their existing structures where preventative maintenance hasn't actually been in place like it should have been. So we can use that project history of the maintenance we're doing in existing structures. There is also a Tuffy model. It's out of, I can't remember all the details off the top of my head. It's out of Australia, University of Australia, I think. We might better get that up. Brendan, you wouldn't have a copy of that there that we'd better show on the screen, would you? We'll just see if our admin can chuck that up. Yeah. So he's just bringing that up, and there's one more question we can. I'll just answer this other question while we're waiting for that to come up. What would it work for preserving concrete stumps under houses? You probably have to know a little bit more about when you say concrete stumps. And what you're trying to achieve there. We could treat the concrete and stop any moisture getting into it, therefore waterproofing it, stopping it breaking down. I think you must mean piles. What is the best finish for concrete and plant rooms and fire stairs? Is epoxy, and does it work for waterproofing if required? Epoxies have got their place. They can be costly. They can be also install can be a mission, especially in plant rooms, fire stairs, very confined. There'll be high fumes. You'd have to do a lot of containment. With our systems, we've got a penetrating sealer that's environmentally friendly, and so therefore they're a bit safer to use as such. So hopefully that answers the question there.
They're all nil VOC, certified nil VOC, so safe for installers and for examples like we've talked about in terms of marine projects, it's safe for the environment as well. They don't need to be contained. And so, yeah, in terms of your plant rooms and fire stairs, it depends on the project, and we'd have a look at it and weigh on what we would recommend, but we have got full waterproofing systems for concrete.
So hopefully you guys can see, can you see that we'll put up, Christine?
Mm-hmm.
Can you see the screen? There's a graph on the screen.
Yes.
Yeah, cool. So thanks, Brendan, for putting that up. It wasn't quite the one I was looking for, but this does explain it. So you got your exposure time here. You've got you see this graph down the bottom. You've got your scale on the left is your damage level, and then you got your exposure time. And what research shows that it's an exponential graph with corrosion in concrete, and it's in those early stages in A and B where we like to assess and have a look at structures before first cracking, therefore. And obviously your structure is going to move right up, and you've got these lines, these further lines out here as some graphs there. Obviously, if we can push it out more, we can extend that durability. This is another way we can talk to asset owners early on and say, listen, we can extend by using modelling, we can extend your structure this far out. There is also a Tutty model that says basically if you spend $1 more at design phase, you save up to $125 at remediation stage. And we can send that graph to you. It's quite interesting. So it's not a large cost early on to put into the project to save big costs at the other end for remedials and that sort of thing. Talking about costs, we're not a high cost either. So we're talking about $40 to $50 maybe a square metre for existing structures, which is pretty awesome when it's a one-time treatment for a structure. We can back you up with a 25, 30-year plus warranty over against putting a silane or siloxane or something like that on a concrete structure where you have to come back and repair it every 5 or 10 years. And when we put a patch on, as I said earlier, on concrete, it's only a surface. All this, if you've got chlorides in concrete, it actually excites them once they're trapped in there, and it's a bandage over a broken bone. It's not really fixing the problem. So by putting a penetrating sealer on, you're obviously inside the concrete, fixing the concrete, stopping that corrosion. So hopefully that's been informative for you guys.
There'll be more before we
just check if there's no more questions there, Christine. We will send out just a questionnaire after this as well, and we'll have our details on so you can contact myself or Christine direct, and we'll put you in touch with the right people if we can't help you. But that's just about a wrap, I think.
Yeah, perfect. Thank you guys for joining us.